Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem using the concepts of vector projections. So as per the problem, for each of the following, determine the scalar and vector projections of x on y. So let's start with part A. So we can find the scalar projection. And the formula for that is x dot y over magnitude of y. Now we can use the given vectors. For magnitude of y, we should square the components of vector y, add them, and apply square root to the sum. So we can do the dot product in the numerator. So we should multiply the x components and y components. In the denominator, 1 square is 1, negative 1 square is also equal to 1. So we get 1 plus 1 equal to 2. In the numerator, 1 times 1 is equal to 1 and 1 times negative 1 is negative 1. 1 minus 1 is equal to 0 and that will make this fraction equal to 0. So this is the scalar projection for vectors in part A. Now we can calculate the vector projection. And for that the formula is x dot y over square of magnitude of y times vector y. So we got the dot product in the scalar projection as equal to 0 and the magnitude is equal to square root of 2. So we square it and vector y is 0 over square root of 2 square is equal to 0. And as per the scalar multiplication, 0 times vector y will be equal to 0 vector. So for vector projection, the answer should be a vector. So this should be the vector projection for part A. Now we can analyze part B. So let's start with scalar projection. So we can use the given vectors. Now we can do the dot product in the numerator. So we'll multiply the x components and y components. And in the denominator, we just get 1. Now in the numerator, 2 times 1 is 2. And 2 square root 3 times 0 is 0. So we are left with just 2 over 1, which is equal to 2. So this is the scalar projection for part B. Now we can find the vector projection. So we can use the given vectors. The magnitude of y is equal to 1. So the result of the dot product is 2. We got that in the scalar projection calculation. So we have to do this scalar multiplication. We have to multiply both components of the vector by 2. So we get, so this should be the vector projection for part B. Now we can analyze part C. So we'll start with the scalar projection. We can use the given vectors. Now we can do the dot product in the numerator. So we multiply the x and y components. So in the denominator, 25 plus 144 is 169, and the square root of that is 13. So this is the scalar projection for part C. Now we can find the vector projection. The magnitude of y is equal to 13. Now we can do the dot product. So the result we got for dot product is 50. So this should be the vector projection for part C. We can leave the answer in scalar product form, because if we multiply the components by 50 over 169, we'll get a long decimal answer. So this can be the final answer for vector projection for part C. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.